This is the review worksheet for Advanced Algebra 1, Topic 6. Been working with uh, rational exponents and exponential growth and decay and exponential functions, and so here's our review. Number one, they give you the fifth root of 4, and you're supposed to write that using rational exponents. So in other words, write it with exponent as a fraction. The exponent on 4 is 1, so that is 4 to the 1/5 power. And like on the quiz, we had trouble with people writing their answer like that. That's obviously not 4 to the 1/5 power, or like this, that's not 4 to the 1/5 power. This is the best way to write your answer and ensure that you're not going to get it wrong. Okay. Number 2, we have 5 to the 3x over 2 times 5 to the x over 4 equal 5 to the second. And our bases already match here, so really I can just put these together, and when I put those together, I would add the exponents. 3x over 2 plus x over 4 equals 5 to the second. And now that I have a single base on each side, I can set those exponents equal. So 3x over 2 plus x over 4 equals 2. And a couple things. I would probably just get a common denominator on the left. So this would be 6x over 4 plus 1x over 4 would be 7x over 4 equals 2 over 1. Cross multiply, 7x equals 8. Divide both sides by 7. X is 8 over 7. And number 3, we have 1/4 to the x plus 1 equals 1/8 to the x plus 2. And I would write both of these as 1/2. Okay, so 1/4 is 1/2 squared, and that's being raised to the x plus 1 power. And 1/8 is 1/2 cubed, and that's being raised to the x plus 2 power. And when I have a power raised to a power, I multiply those exponents. So that's 1/2 to the 2x plus 2 equals 1/2 to the 3x plus 6. And I can remember this problem on the quiz, and the issue was many of you distributed the 2 to the x, but then you did not distribute the 2 to the 1 as well. Okay, the 3 gets distributed to the x, it also gets distributed to the 2. That's where I get the 3x plus 6. So now 2x plus 2 equals 3x plus 6. I'm going to move 2x to this side and get 2 equals x plus 6, and then I'm going to subtract 6. Negative 4 equals x. I also did this another way back when we were solving these, and that was to take 1/4 and raise it to 2 to the negative 2 power. And 1/8 is 2 to the negative 3 power. And, whichever way is easier for you, we're going to get the same answer either way. Okay. Number 4 is 5x, 5 to the x to the 1/3 over 5 to the 1/3 equals 5. So the bases all match. I just need to get my exponents together. This is power to a power, so I multiply. I have 5 to the x over 3 over 5 to the 1/3 equals 5. And then that becomes 5. When I'm dividing, I subtract the exponents. And the exponent over here is 1 because it's not written. So x over 3 minus 1/3 equals 1. And I would probably add 1/3 to both sides and get x over 3 equals 4/3. And then if I cross multiply, 3x equals 12, x is 4. Dividing both sides by 3 there. Number 5, we have f of x equals 3 to the x. And I don't know if you've noticed, but I try to keep those as 2 or 3 because, you know, once we get up 4 to the x, the exponents get large fast. They're makes it a little bit more difficult to graph. So to graph this, I'm going to make a chart, and I'm going to plug in 0, and 3 to the 0 power is 1. And I'm going to plug in 1, and 3 to the 1 power is 3. And I'm going to plug in 2, and 3 squared is 9. I'm going to plot these points. 9 is way up here. Then obviously I need some points over here, so I plug in -1, and I get 1/3. And then it's just going to keep getting closer to that axis. Never going to touch it. And there we go. The domain, there's no restriction on x. The domain is all real numbers. The range, y is never going to have anything down here. So y is greater than 0. The asymptote, the equation of the asymptote is the x-axis, and the equation of the x-axis is y equals x. And the y-intercept is the ordered pair 0, 1. And that's everything we're supposed to do for that. And then we have number 6, write an exponential function. Well, f of 0 is 3. And it looks like we're going to put this in the form f of x equals 3 times, or I'm sorry, I meant to put generic form first, a times b to the x. And a is my starting point. So what do I get when I plug in 0? I get 3. And then b is what I'm multiplying by each time. And so it looks like in this, I'm multiplying by 3. And so it's going to be 3 times 3 to the x. And actually, there is a way for us to simplify that, but we are not going to. We're going to leave it like that because that's what makes the most sense in working with the exponential functions that we're working with. Okay. Number 7 says write an equation for exponential growth, and the initial value is 2,000, increasing at a rate of 8%. So we write f of x equals 2,000 times the quantity 1 plus 0.08 to the x, and we clean that up and we write 2,000 times 1.08 to the x is the final answer. Number 8, the population of a town is 18,000, and it grows at 6% per year. What will the population be in 5 years? So again, we're going to use just the exponential growth model. F of x equals a times 1 plus r the x. So our initial value is 18,000, and 1 plus 0.06. And if I clean that up, I get 18,000 times 1.06 to the x. And I want to know what the population is going to be in 5 years. So f of 5 is 18,000 times 1.06 to the 5th power. Then we have to rely on our calculators to get us the right answer. And if you're not getting the correct answers with your calculator, then you haven't figured out how to plug it into your calculator and get the right answer, obviously. So what I've shown most of you with your TI-30s, okay, this calculator is different. It has a bit different functionality, and actually it makes it a little bit easier to plug in. But what I've shown you with your TI-30s is do the 1.06, and you can put that in parentheses if you want to. 1.06 in parentheses, and then raise it to the 5th power, okay, and hit enter, and then multiply that by 18,000. And we get 24,088.0604. And then we go back and I guess I didn't put in the directions what to round to, but if we're talking about number of people, I really can't have a part of a person. So let's round this to the nearest whole number. So population of 24,088 people. Number 9, Leo invests $9,000 at an interest rate of 6%, compounded quarterly. Okay, how much is the investment worth at the end of 10 years? So the formula, the equation that we're going to use for that is A equals P times the quantity 1 plus R over N to the NT. And the P is the principal, that's what we're starting with. The R is the rate, N is how it's compounded. In this case, compounded quarterly, so N is 4, and then T is the time. So we're going to have 9,000 times 1 plus 0.06 over 4 to the 4 times 10. And again, on your calculator, sunshine coming in there. On your calculator, what I've shown most of you is to do parenthesis 1 plus 0.06 divided by 4, close that parenthesis, and raise it to the 40th power. Do that multiplication in your head, or do it ahead of time, or something. But needs to be to the 40th power, and then multiply by the principal. So then times 9,000. We get 16326.16568. And when we're talking about money, we round to the hundredths place. So my answer would be $16,326.17. 10. The population of a town is 50,000. Decreases at a rate of 4%. About how many years will the population be fewer than 30,000? Okay, so again, we're going to use f of x. This is just exponential decay. So the quantity a times the quantity 1 minus r to the x. So our initial amount is 50,000. And then times 1 minus 0.04 to the x, or 50,000 times 0.96 to the x. And then it's just a guess and check game, right? I'm going to take and put into my calculator 50,000, then parenthesis 0.96, and I'm going to raise it to the 10th power, and I get 33,000. And so I need to go more. I'm going to raise it to the 15th power, and I get 27,000. So obviously too much. So I'm going to enter it again and maybe try, what did I do first? 10th, maybe try to the 12th. Oops, that's 112. There we go. And that's 30,600. So maybe to the 11th. And that's 31. So maybe I think the 13th is going to be underneath. Let's try it. 29.4. So which one's closer to 30? 29.4 or 36? Nah, they're about the same. So I'm going to go out and I'm going to say it's going to be 12 years. Approximately 12 years. On a problem like this, I would also probably accept 11. Oh, I'm sorry, not 11, 13. That little squiggly just means approximately. So I would probably accept either one of those answers. I don't know what the numbers are on the one on the test, and you put in 12 or 13, it may come out closer to 30,000. As it was, to the 12th power is about 600 away from 30,000, and to the 13th power is about 600 away from 30,000. So that's why I would accept either one there. Number 11. Sequence 14, 7 halves, 7 fourths, 7 eighths, and so on. Is it a geometric sequence? Let's see. Multiply by 1/2, I get that. 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 So yes, it is a geometric sequence, and the common ratio is that thing I'm multiplying by each time. The common ratio is 1/2. So, number 12, what are the explicit and recursive formulas for the sequence? 5, 15, 45, 135, 405, blah, 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 blah. well, let's see, the common ratio there is going to be 3. 15 divided by 5 is 3, or 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135, and so on. So for the explicit formula, A of n is A sub 1 times r to the n minus 1. And so we take A of n is the first term, which is 5, times 3 to the n minus 1. Okay, and for the recursive formula, our recursive definition is A of n equals A sub n minus 1 times r. And I have to tell you what A sub 1 is. So the recursive formula for this, A of n equals A sub n minus 1 times 3. A sub 1 is 5. So you take the previous term, you multiply it by 3, you get the next term. And the starting term is 5. Number 13. Recursive formula for a geometric sequence is A of n equals 3 times A to the n minus 1 with an initial value A of 1 equals 1/4. So that means that the first term is 3/4. The next term would be 9/4. The next term would be 27/4. The next term, da 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 da. They want the recursive formula, so A sub 1 times r to the n minus 1. A sub 1 is 1/4 times r. R is 3 to the n minus 1. And that would be the explicit formula. And number 14. Let's see, number 14 up here. I believe it's our last question. 14. Yep, it is. We have the equation f of x, or I'm sorry, g of x equals 2 to the x plus 5. And how does that differ from f of x, the parent function, 2 to the x? When it's plus 5 down here, it's moving up or down. Okay, and so because that's plus 5, it's going to be the give me 1 second here. To move the graph up 5. If that were negative, it would be down 5. If that were 2 to the x plus 1, that would go left. Okay, or if it were, what haven't I used? K of x is 2 to the x minus 2, that would go left, right. Okay, so when it's out here, that goes up or down. When it's up here, it goes left or right. Okay. All right, that is that.